Small gas engine inspection, measurement, and cleaning. This video will continue your study of small gas engines by summarizing proper techniques for inspecting and servicing engine components to prepare for reassembly. The video will stress the importance of close inspection and accurate measurement of part wear during an engine rebuild. It will help you avoid the mistake of reinstalling a bad part in an engine, an embarrassing mistake that can lead to rapid engine failure. If the cylinder block and crankcase cover are coated with a heavy layer of oil deposits, wash them off in a cold solvent tank before beginning. Removing this grime will allow for easier inspection and a more professional work environment. For now, simply remove the heaviest deposits because your inspection may find the block to be unusable in the rebuild. To begin block inspection, closely check the cylinder bore. Look for deep scratches, scoring, and other imperfections. If you had to remove a ring ridge, the cylinder is badly worn. The block would have to be bored, re-sleeved, or replaced. With a two-stroke cycle engine, check the ports. A broken ring or other debris could have chipped and gouged the port openings. If the head is cast as part of the block, check the combustion chamber for damage. You must determine if the amount of wear or damage will affect engine operation. In addition, look for other problems in the crankcase. Check for scored bearing bores, cracks, and other problems. If you had a major engine failure, such as a broken rod or oil starvation, you must find every part that was damaged. For example, when a rod breaks at high RPM, chunks of metal become projectiles that can ruin other parts. A piece of rod blew a hole in this crankcase. Look for stripped threads. This is an especially common problem in aluminum blocks. Repair damaged threads before beginning reassembly. If the valve seats are in the block, inspect them closely for burning, physical damage, or wear. Also, check for cracks between the seats. Inspect the other areas of the block for troubles. For instance, you should check for wear at the governor lever now to avoid fixing it after you have finished your rebuild. Next, measure cylinder bore wear. When using a dial bore gauge, adjust your micrometer to the specified bore diameter. Then, adjust the dial bore gauge to read 0 when inside the micrometer. Slide the dial bore gauge up and down in the cylinder to make your readings. If the cylinder is unworn, the dial bore gauge will remain at 0. If the dial registers 1/1000th, for example, you have 1/1000th of an inch wear in the cylinder. Sliding the bore gauge up and down will allow you to check for taper at the top, center, and bottom of the cylinder. By rotating the cylinder bore gauge 90 degrees, you will also measure out of round. The cylinder may be worn more in one direction than the other. If not removed earlier, pop out any crankcase seals. You can drive them out from the rear with a pin punch. You can also pull them out with a pry bar. However, be careful not to nick or gouge the engine surface, or an oil leak could develop. To measure bearing bore wear, compress a hole gauge and lock it. Fit the gauge into the bore and turn the screw so the gauge ends open. Tighten the gauge screw to lock your setting. Then, remove the gauge from the bore and measure it with an outside micrometer. Compare your measurements with factory specifications to determine if the bearing surface is worn too much. If the bearing is removable, the block can easily be repaired by removing the old bearing and installing a new one. However, if the bearing is machined as part of the crankcase, It is probably better to buy a new crankcase than trying to repair the bearing surface. Repeat your measurements on all bearings in the cylinder block and in the crankcase cover, like this one. If you fail to locate a badly worn bearing, engine failure, knocking, or seal leakage can ruin your engine rebuild. Taking the time to measure high friction points in an engine is time well spent. To replace a bearing insert, mount the case or cover on wooden blocks on your bench so the bearing has clearance above the workbench. Find the correct size driver that fits into the bearing and bore. Then use moderate hammer blows or a hydraulic press to force the old bearing out and the new one in. Continue service by removing any large gaskets still on the cylinder block. Then use an abrasive pad to polish the surface where gaskets must seal. If you must use a scraper to remove gasket material from the cover, scrape carefully. You do not want to gouge or nick the soft aluminum because this could result in an oil leak. Continue cleaning the remaining gasket material by using an abrasive pad and an air grinder. Never work in one location too long, or you could remove metal and make the sealing surface untrue. Next, you are ready to deglaze the cylinder if necessary. This is done with a cylinder hone mounted in an air or electric drill. Deglazing is sometimes recommended by the engine manufacturer for cast iron cylinders and aluminum cylinders that are used with chrome rings. This technician is using a rigid hone to remove a small amount of taper from a cylinder. The hone must be adjusted outward until the cylinder cleans up. To avoid injury or damage to the hone, do not let it slide out of the cylinder too far. Only allow the stones to extend about an inch out of the cylinder so that they don't catch in the crankcase or extend out the top of the block. Also, never overhone the cylinder or it could be machined too large. Only hone enough to clean up the surface. Although it does not correct out of round and taper, a flex hone is used to produce the proper texture and crosshatch pattern on the cylinder wall. A crosshatch pattern will help ensure proper piston ring break-in and sealing. To use a flex hone, spray the hone with a light lubricant. Then spin the hone with a drill while moving it up and down quickly enough to produce a crosshatch pattern. Stop honing when you see a light crosshatch pattern formed in the metal. You will probably have to wipe the cylinder down to check for a good pattern. After honing, it is critical that you remove all hone grit from the engine. First, soak a clean rag in a soap and water solution. Wipe the cylinder down with a soapy rag. This will lift and remove most of the stone grit and metal bits left after honing. Dry the cylinder thoroughly. Next, pour motor oil onto another clean rag. Spread the oil around on the rag. Then, wipe the cylinder down again. Wiping the bore with an oil-soaked rag will lift and remove any remaining debris from the hone marks. Keep wiping until the rag comes out clean. The cylinder heads should be cleaned as just described for the cylinder block and crankcase cover. Carefully use an abrasive pad on the cylinder head gasket surface without damaging it. Use a scraper to remove any heavy carbon deposits inside the combustion chamber. After scraping, remove any remaining carbon with a wire brush mounted in a drill. Be careful not to nick or gouge the valve seats with the metal body of the wire brush, or the head could be ruined. Use smaller wire brushes to remove any deposits in the cylinder head ports and in the valve guide. Clean any debris from the cooling fins to prevent engine overheating. This is also true when servicing the cylinder block. Use an abrasive pad on the gasket surfaces for the intake and exhaust ports. As you are cleaning parts, watch closely for cracks, burning, and other damage that must be corrected. Wash the head in a cold solvent tank to ready it for measurement. With the head clean and dry, you can measure to check for surface and part wear. To check for valve guide wear, use a small hole gauge. Fit the gauge down into the guide in the most worn area, which will be near the top or bottom of the guide. Then, mic the hole gauge with an outside micrometer. Compare your measurements with specifications. The guides will have to be replaced or knurled if worn too much. To check the head for warpage, place a straight edge on the gasket surface. The thickest feeler gauge that fits between the head and the straight edge equals warpage. Replace or resurface the head if warped. Since a piston suffers from tremendous loads and high temperatures, check the piston head for physical damage and burning. Make sure the skirts are not scored or broken. This piston boss was damaged severely by connecting rod failure. Generally, inspect these 4 critical areas on a piston. Most problems will show up in these areas. If you can detect any play at the piston pin or rod small end, disassemble these parts for further measurement. Also inspect the rod's big end for scoring or abnormal wear. Replace the connecting rod if you find any problems. To measure piston wear, mic across the piston skirts in line with and at a 90-degree angle to the piston pinhole. Compare actual piston diameter with specifications to determine the condition and usefulness of the piston. Piston wear equals specified diameter minus measured diameter. If the piston is still usable, remove the old rings. You can use a ring expander tool to open and remove the old rings. However, it might be easier to use your fingertips to remove them. Scrape off any carbon deposits on the piston head while being careful not to gouge the piston. Then, use a ring groove cleaner to remove any carbon deposits inside the piston ring grooves. To remove the piston pin, disengage the snap ring. This can often be done with a small, pointed tool. With other snap ring designs, it is easier to use pliers. To remove the piston pin, use the appropriate size driver and light blows to push the piston out of the rod and piston boss. This will let you lift the piston off the connecting rod. If the piston checks out okay, wash it in solvent to ready it for reassembly. To mic the connecting rod big end, torque its cap bolts to specifications. Then use a hole gauge to measure rod big end diameter. If you find that wear is beyond factory recommendations, always replace the rod. Measure the rod bore in several locations to make sure that the bore is not out of round. By comparing your crankshaft measurements with the rod bore diameter measurements, you can calculate rod bearing clearance. Bore, or bearing inside diameter, minus shaft diameter equals bearing clearance, which is very critical to engine life. If the rod big end is okay, mic the small end using a hole gauge. Also mic the pin bore in the piston. When measuring piston pin wear, mic the most worn area of the pin, usually on the surface that contacts the rod. These measurements will let you calculate clearances which are critical to engine service life. For example, piston bore diameter minus piston pin diameter equals piston pin clearance. This is also true for the rod's small end clearance. If these parts are usable, wash them in a cold solvent tank to ready them for reassembly. To inspect the crankshaft, check the snout threads for damage. Make sure the keyway is not worn and that all journals are in good condition. Check on both ends of the crank. It is very easy for the drive end to be damaged. Here is a badly damaged rod journal. This crank will have to be reground or replaced. To measure wear, measure the rod journal in at least 2 places to check for out of round. Also, measure the crank main journals. Again, by comparing your previous rod and bearing measurements, you can calculate clearances to determine if they're acceptable. If it is in good condition, wash the crankshaft and blow it dry with compressed air. If there are oil holes through the crank, make sure they are blown out and perfectly clean. If your engine uses an oil pump, use a feeler gauge to check inner rotor to outer rotor clearance, as well as pump body to outer rotor clearance. Both are critical to oil pump service life and pressure. Also use plastic gauge to check rotor to cover plate clearance. Place the plastic gauge on the rotor. Bolt the plate into place, remove it, then compare the plastic gauge to the paper scale. It will give clearance in thousandths of an inch. Inspect each valve for obvious problems. Look for abnormal tip wear, stem wear or scoring, and valve face wear or burning. If the valves look good, use a wire wheel to remove carbon deposits from the valve neck and head. Wear eye protection and leather gloves to prevent injury. Use an outside micrometer to check actual stem wear. Mic the stems in the most worn locations and compare your measurements to specs. Replace the valves if their stems are worn too much. By comparing stem diameter with guide diameter, you can calculate valve to guide clearance. If the stem is loose in the cylinder head, it can lead to rapid seal failure and high oil consumption. Oil can be drawn into the port and combustion chamber on each intake stroke. Some service manuals give a valve spring's free length specification. If the springs are too long or short, or if the engine has seen a great deal of use, replace the valve springs. Also inspect the retainers and keepers for wear and replace them if needed. Check the gears on the crankshaft and camshaft. Look at each gear tooth to try to find any that are damaged. Replace the cam or crank if the gears are not in good condition. Use an outside micrometer to measure the cam journals and cam lobes. Again, if they're worn out of specs, replace the camshaft. If a cam lobe is worn, it will affect engine power and efficiency. If you see pits on the cam lobes, this is another reason to replace the cam shaft. Inspect the bottoms of the tappets for signs of wear. If the cam is replaced, you will likely want to also install new lifters. Inspect the tips of the push rods. Look for a slight imperfection or pitting caused by wear. Roll the push rods on a level surface to make sure they are not bent. Replace them as needed. Inspect the rocker arms where they contact the valves and the push rods. Also, inspect the inside of each rocker arm to make sure they are not worn. A valve job resurfaces the valve seats and faces to ensure normal engine compression. To begin, install the correct diameter pilot shaft into a valve guide. It must fit tightly. Then, select the correct cutter. Determine whether the seat angle is 30 or 45 degrees. The cutter will usually add a 1 degree interference angle to aid valve sealing. Adjust the cutters so that they contact the seat without hitting the block or head area around the seat. Place the cutter on the seat and turn it with the T-handle to clean up the seat surface. Hold the T-handle squarely and push down lightly while turning the cutter in the right direction, usually clockwise. Only cut enough away to make the seat shiny all the way around. Do not cut too much, or you will sink the seat lower into the engine. After a few turns of the cutter, inspect the cut seat again. If you still find dull, black areas, you may have to replace the seat or the cylinder head. Before cutting the next seat, use a brush to clean metal shavings out of the cutters. Then, cut the next seat in the same way. Do not lubricate the cutter. It should be dry while in use. Again, inspect the seat closely after a few revolutions of the cutter to make sure it is cleaned up and no dark areas can be seen. A 60-degree stone or cutter may be used to narrow the seat if the seat is too wide. This will remove metal from the inside diameter of the seat and narrow it down. Similar cutters can be used to resurface the valve faces. First, find the sleeve that fits properly over the valve stem. Then fit the sleeve into the cutter. The sleeve holds the cutter in alignment on the valve stem. If necessary, adjust the cutters for the diameter of the valve head. The cutters must contact the valve face properly. Clamp the valve stem into a vise, making sure to use vise caps to prevent damage to the valve stem. While pulling up on the tool lightly, rotate the cutter on the valve. Make sure you're turning the cutter in the right direction or you will dull the cutter. An arrow is often provided to show direction of cutter rotation. Only make 3 or 4 revolutions of the cutter, then remove the tool and inspect the valve face. Just like the seat, it should be clean and shiny all the way around. A valve grinding machine can also be used to resurface a valve face. It uses a large grinding stone to remachine the valve face. When using a stone, cutting oil must be fed down over the valve to cool it and remove grinding grit. A valve grinding machine can also be used to resurface the valve stem tips. Remove as little material as possible to clean up the surfaces. Valve grinding compound can be used to check your valve job. Wipe a little grinding compound onto the valve face. Spread it all the way around with your finger. Place the valve into its guide. Then, use a lapping stick to rotate the valve on its seat. Lift and rotate to spread the lapping compound. The compound will smooth and dull the mating surfaces, making their contact points visible. Remove the valve and wipe it off. Then, inspect where the face is touching the seat. The valve face will be dull where it is contacting its seat. This will tell you if the valve seat is too wide and if it is touching all the way around the valve. Clean all the remaining parts and blow them dry. Now that you understand proper methods for inspecting, cleaning, and measuring engine parts, you are ready to learn engine reassembly procedures.